This is Leetcode 418 sentence screen fitting. So we have an input array, which is going to be a bunch of strings for the sentence, and we're going to take in a rows count and a columns count. So our goal here is to be able to determine how many times we can fit the entire sentence on the screen, where the screen is denoted by the rows and columns. So the first thing that we want to do is we want to take the original input array and we want to join it to make one long sentence. And at the very end, we want to have a space. And we basically want to create this string because we want to kind of simulate an infinite repeating sequence of the sentence. And so at the very end, we need this empty space because if we tack this onto the very end of it, then the next sentence would have a space between the last word and the start of word of the next sentence. So we want to do the concat, and then we also want to keep track of the length of the concatenated string because later we're going to do some operations around that. We're going to set current IDX to be 0, and that's going to represent the position in the concat string that we're currently inspecting. And we're going to instantiate a fit count. Fit count is what we're going to return at the very end of determining how many times we're able to fit the sentence on the screen. So we're going to have a while loop. While rows minus minus, basically we want to see how many rows we could put our sentence on. And for a given row, we want to increment current IDX by columns. Now, the reason for this is, let's say our columns is 8, right? And current IDX starts at 0. So current IDX is going to become 8. Now, we want to update fit count because let's say our sentence was only like 2 letters long, but where our current IDX is now at 8, meaning we were able to fit a word multiple times into that current row. So we do fit count plus equal math.floor current IDX divided by lane. And we want to use floor because we want to know how many complete sentences we were able to put. We don't care about the remaining kind of indices that we were not able to put into the row. So we do math.floor current IDX, which is going to be, say, 8, and length of the string. And the string length was going to be, this is 5, 10, 11, so it'll be 11. So if fit count, we want to increment it by whatever the whole numbers that we got from this division. And after that, we want to determine where in the next row we may want to start at. We do cur IDX modulo length because remember cur IDX was 8 and length of the string was going to be 11. So well, if we do modulo of that, then 8 mod 11 is actually going to give back 8 again because that's the remainder. So we start from 8. Now, there are 3 cases that we want to check. If cur IDX equals length minus 1, meaning we've landed on the very last character of concat string, we've landed on the very last one, then that means we could put the entire string on the row. So we would update fit count, and then we would reset cur IDX to be 0 because this is what we're going to do on the next row. Else if the concat of cur IDX is a space, then that means we just fit perfectly at the end of the row. So then we would increment cur IDX to start with the next word. Remember, cur IDX was 8, but now we would increment cur IDX to be 9. Finally, we have, in the else case, we have a while loop. And let's say we landed somewhere that's not the very end, and it's also not a space. This means that we need to perform a backtracking to continue left in the array, in the concat string until we find the start of the word. So we're going to be looping while cur IDX is greater than 0 and concat of cur IDX minus 1 is not an empty string. Cur IDX minus minus. And this will get us back to the start of the next word. At the very end, we return fit count. So this is how you solve the problem.